Yes, conductivity. So conductivity is the reciprocal of specific resistance. It is represented by the symbol sigma. Yes, it is represented by the symbol sigma. And its formula is sigma is equal to 1 by rho. Rho is resistivity. Okay, resistance is R, resistivity is rho, and the reciprocal of rho is sigma, that is conductivity. So the SI unit of conductivity is the reciprocal of the SI unit of resistivity, which is ohm raised to minus 1 multiplied by meter raised to minus 1, which you can see over here. Ohm raised to minus 1, meter raised to minus 1. Its symbol is like this, or it is also known as Simon per meter. Simon per meter. So that is conductivity, which is 1 by rho. इसके ऊपर कोई न्यूमेरिकल जनरली नहीं पूछते हैं, बट कभी फिल इन द ब्लैंक्स या फिर ऑब्जेक्टिव टाइप क्वेश्चन में इसका क्वेश्चन आ सकता है कंडक्टिविटी का. बाकी इसका कोई इतना इम्पोर्टेंस नहीं है. उसके बाद चॉइस ऑफ मटेरियल ऑफ अ वायर भी हमने पढ़ा था, वीडियो में मैंने डिस्कस किया था. सुपर कंडक्टर्स एक नया टॉपिक है तुम्हारे लिए. सो दिस आई हैव नॉट टॉट टिल नाउ. So experimentally it is observed that the resistance of some substances like tin, lead, etc. decreases tremendously with decrease in temperature and becomes almost zero in the low temperature range near absolute zero. मतलब टिन, लेड और ऐसे कुछ सब्सटेंसेस हैं, अगर इनका टेम्परेचर कम करेंगे तो इनका रेजिस्टेंस ज़ीरो बन जाता है. मतलब टेम्परेचर रेंज नियर एब्सोल्यूट ज़ीरो. Now let's see who can tell me what is absolute zero. Neelam, are you there? Neelam?
Yes, sir.
Yes, Neelam. Can you tell me what is absolute zero?
So it is quantity near to zero.
No, it is a temperature. Do you know its value?
Sir, I don't remember.
Okay. Uh,
0 Kelvin.
0 Kelvin, absolutely correct. Can you tell me its value in degree Celsius?
Minus 273 degrees Celsius.
Very good. So absolute zero is around minus 273 degrees Celsius or 0 Kelvin. In the temperature range near absolute zero, these materials, tin and lead, they behave like superconductors, means their resistance becomes zero. Now all of you are aware about what is resistance, but I would still like to ask some people. Let me ask Angelina.
Yes, sir.
Beta, what is resistance? Angelina, I cannot hear you.
Sir, I'm here. I'm here.
Yes. Can you tell me what is resistance?
Mm, Sir, I'm not. I'm unable to explain.
Have you seen my videos?
Yes, sir.
So I have explained very clearly in that what is resistance. It was a big topic in that.
Yes, sir.
Okay, let me ask Priyam. Are you there? Priyam. Priyam, are you there? Tanisha, are you there?
Yes, sir.
तनीषा, ये गाना क्या बज रहा है तुम्हारे पीछे?
Sir, I'm not. I'm unable to explain.
Yes. Can you tell me what is resistance?
Sir, I'm unable to explain.
Resistance is the response of a particle to a force.
Just a second. Yes, sir.
Tanisha, can you tell me what is resistance?
Sir, I don't remember.
Beta, are you prepared for tomorrow's exam? Because if you don't know resistance, how can I teach you the further topics? मेरे को internal resistance सिखाना है तुमको. कैसे सिखाऊंगा internal resistance अगर resistance नहीं पता है तो? किसी और को पता है resistance का meaning?
Sir, it is the obstruction offered to the flow of current.
Very good, Pratik. It is the opposition or obstruction offered to the flow of current in a conductor. इसका पूरा थियरी मैंने वीडियोस में एक्सप्लेन किया है जो कोई भी रायन के बच्चे ने देखा नहीं है अब तक, मुझे ऐसा लग रहा है. सो आई डोंट नो व्हाई आई एम कंडक्टिंग दिस क्लास फॉर यू. एनीवेज इट्स ओके, कुछ नहीं कर सकते, मजबूरी है मजबूरी, कोई बात नहीं. तो सुपर कंडक्टर्स में रेजिस्टेंस जीरो हो जाता है व्हेन देयर टेम्परेचर इज डिक्रीज्ड अप टू एब्सोल्यूट जीरो and current can flow in the conductor without any obstruction. And because the resistance is zero, the current never decreases. It keeps on flowing and it remains in the conductor till a very very long time. So इसके examples ये लोगों ने दिए हैं यहाँ पे. Example is mercury below 4.2 Kelvin, lead below 7.25 Kelvin, and niobium below 9.2 Kelvin. These are all superconductors. Superconductors are not in common use since it is very difficult to achieve such a low temperature. However, they can be very useful if it is possible to obtain them at room temperature. The size of computers could then be reduced to a few centimeters and power lines could then be made as thin as single wire. अगर सुपरकंडक्टर को अचीव कर लिया हमने, उसको हमने बना लिया सुपरकंडक्टर्स को, so we can reduce the size of these objects like power lines and computer to a very very small area. Okay, and that would actually make our life very very easy. That is superconductors. तो इतना था फर्स्ट पार्ट में. मैं फिर से तुम्हें पूछ रहा हूँ फर्स्ट पार्ट में और कोई डाउट्स किसी को है तो प्लीज़ पूछो मुझसे, नहीं तो ये ऑप्शन में छोड़ना पड़ेगा चैप्टर पूरा अगर तुमने वीडियो ही नहीं देखा है तो. ठीक है, तो सॉल्व्ड एग्जांपल में जाते हैं. Okay, first solved example of part A. Figure 8.8 shows IV graph of two conductors A and B. Do you know what is IV graph? This is current versus voltage graph. IV graph is current versus voltage graph. IV ग्राफ जब स्ट्रेट लाइन होता है इसका मतलब है फॉर दैट पर्टिकुलर कंडक्टर द ओम्स लॉ इज ओबेड. मतलब कंडक्टर ए और बी ये दोनों के जो IV ग्राफ है वो स्ट्रेट लाइन है. इसका मतलब है दोनों ओमिक कंडक्टर्स हैं. तो यहाँ पे क्वेश्चन पूछा है विच ऑफ द कंडक्टर इज ओमिक. तो आई विल राइट बोथ ए एंड बी. दोनों ओमिक कंडक्टर्स हैं. ओमिक कंडक्टर्स क्यों हैं ये? बिकॉज ओम्स लॉ इज ओबेड, ओम्स लॉ इज फॉलोड और ओबेड by both these conductors, hence they are ohmic conductors. इसके बाद है which conductor has more resistance and give reason to your answer. तो IV ग्राफ का एक कैरेक्टरिस्टिक है, जितना ज़्यादा स्लोप IV ग्राफ का, जितना ज़्यादा स्लोप उतना ज़्यादा रेजिस्टेंस, क्योंकि स्लोप ऑफ IV ग्राफ इज नथिंग बट रेजिस्टेंस, तो जितना ज़्यादा स्लोप उतना ज़्यादा रेजिस्टेंस. वैभव, आर यू देयर? वैभव,
यस सर.
वैभव मुझे बताओ, कंडक्टर ए और बी दोनों के ग्राफ है तुम्हारे सामने, इनमें से स्लोप किसका ज़्यादा है, ए का या बी का? कंडक्टर ए और बी दोनों के ग्राफ तुम्हारे सामने हैं, किसका स्लोप ज़्यादा है? कौन सी लाइन ज़्यादा स्लैंट है, उसका स्लोप ज़्यादा होगा?
सर ए.
वेरी गुड. तो ए का स्लोप ज़्यादा है, इसका मतलब है ए का रेजिस्टेंस ज़्यादा है. तो यहाँ पे क्वेश्चन है विच कंडक्टर हैज़ मोर रेजिस्टेंस एंड गिव रीजन टू योर आंसर. तो आंसर है ए. Conductor A has more resistance because its graph has greater slope, and since slope of IV graph represents resistance, conductor A has got greater resistance. ठीक है, चलो आगे बढ़ते हैं. तो ये तुम्हारा, एक मैंने गलती की है, यहाँ पे IV ग्राफ का स्लोप है और हमें VI ग्राफ का स्लोप रेजिस्टेंस मिलता है. यहाँ पे हमें मिला है रेसिप्रोकल ऑफ रेजिस्टेंस, कंडक्टेंस. यस, सो लेट मी करेक्ट माई सेल्फ ओवर हियर. ठीक है, सब लोग के लिए एक अच्छा नोट करने का अपॉर्चुनिटी है. स्लोप ऑफ VI graph is resistance. Slope of VI graph is resistance. ठीक है, therefore slope of IV graph is equal to 1 upon resistance, which is conductance. Slope of IV graph क्या है? 1 upon resistance, which is conductance. Okay, so greater slope means greater slope of IV graph means greater the value of 1 upon resistance. मतलब reciprocal of resistance will be greater. That means resistance will be smaller, and smaller the value of resistance. So because ये IV ग्राफ है, we cannot treat it like VI ग्राफ. यहाँ पे जितना ज़्यादा स्लोप उतना रेजिस्टेंस कम हो जाएगा. तो ये मेरा रिलेशन उल्टा है, बिकॉज दिस इज IV ग्राफ. ठीक है, तो विच कंडक्टर हैज मोर रेजिस्टेंस, उसका आंसर अब उल्टा हो जाएगा. कंडक्टर B विल हैव मोर रेजिस्टेंस. Let's go to the next question. फिगर 8.9 shows VI ग्राफ. अब देखना यहाँ पे पहले IV ग्राफ दिया था, ये है तुम्हारा VI ग्राफ, जो तुम्हारा जनरल ग्राफ होता है बिटवीन वोल्टेज एंड करंट, जिसका स्लोप होता है रेजिस्टेंस. IV ग्राफ का स्लोप होता है कंडक्टेंस, रेसिप्रोकल ऑफ रेजिस्टेंस. ठीक है. So experimentally obtained VI graphs value in different cases are shown here. Select the graph for ohmic and non-ohmic resistors. Ashmit, are you there?
Yes, sir.
Which one is ohmic and which one is non-ohmic? Can you tell me?
The first and the second one is ohmic, and the C and D is non-ohmic.
Okay, can you tell me the reason?
Because it has straight line.
The first and third graphs are straight lines, hence they are ohmic. The third and the fourth graphs are curved lines, hence they are non-ohmic. You are right. So whenever VI graph is a straight line, it is the graph of ohmic conductor, and whenever VI graph of a conductor is a curved line, it is the graph of non-ohmic conductor. So this means that pure metal is ohmic. Copper sulfate solution with copper electrodes behaves as an ohmic conductor, but filament of a bulb and junction diode. Now you must be wondering, what is junction diode? Junction diode is a electronic component made up of semiconductors. Electronic component. So junction diode has junction diode is non-ohmic resistor because its VI graph is a curved line. Okay, let's go to the next question. Chalo, let's see and ask Shreya.
Yes, sir.
Please help me. Calculate the potential difference required across a conductor of resistance 5 ohm. ठीक है, तो मुझे रेजिस्टेंस दिया है 5 ohm. Calculate potential difference. V ढूंढना है मुझे. To pass a current of 1.5 ampere through it. Current I 1.5 ampere. बताओ कौन सा फॉर्मूला यूज करेंगे?
Sir, V is equals to IR.
वेरी गुड. V इज इक्वल टू IR. ये है ओम्स लॉ का फॉर्मूला. ओम्स लॉ. V is equal to IR. So V is equal to 1.5 multiplied by 5, which is 7.5 volt. पोटेंशियल डिफरेंस का सिंबल V है और पोटेंशियल डिफरेंस का SI यूनिट वोल्ट है, उसका भी सिंबल V है. ये भी मैंने बताया था वीडियो में. ठीक है, बहुत इजी है. 7.5 वोल्ट. लेट्स गो टू द नेक्स्ट क्वेश्चन. नीत, आर यू देयर? नीत. Priyam, are you there? Priyam, I cannot hear you.
Yes, sir, I'm there.
Yeah, speak loudly, okay? An electric gadget draws a current of 200 milliampere. कितना करंट है बेटा?
200 milliampere.
I cannot hear you. Please speak loudly. Keep your microphone near your mouth.
Sir, am I audible?
Yeah, but speak loudly. No, your
Yes,
voice
sure.
is very faint. Okay, I want to convert this milliampere into ampere. How do I do it?
So divide by
Sir,
10 raised to
200
3.
to
Divide by
10
1000 or
minus 3.
multiplied by 10 raised to minus 3. You are right. So this is ampere. Okay, now we cut there are just two zeros here. We cut these two zeros over here, so we get 2 by 10, which is 0.2 ampere.
0.2 ampere.
Very good. Now battery is of 12 volt. Find the resistance. Yes, Priyam, what is the formula?
Sir, V upon I.
See, V is equal to IR is your Ohm's law. So you need to, opening statement, you need to write this. Now you need to find the resistance. So V upon I is equal to R. You are correct. So R is equal to 12 by 0.2, which is 120 by 2, which is 60 ohms. 60 ohms. This symbol you see, all of you, this is the symbol of SI unit of resistance. The SI unit of resistance is ohm. OHM. मैंने वीडियो में बताया था इसके बारे में. जॉर्ज साइमन ओम एक साइंटिस्ट था, जर्मन साइंटिस्ट, जिसके नाम पे जिसने काफ़ी रिसर्च किया था इस टॉपिक पे, उसके नाम पे ये सिंबल रखा गया है. और इसका जो सिंबल का मीनिंग है दैट इज ओमेगा. ग्रीक लेटर है ये ओमेगा, और इसको बोलते हैं ओम. 60 ओम्स. लेट्स चेक द आंसर. ऐसे ही सिंपल क्वेश्चंस आने वाले तुमको. हम लोग कॉम्प्लिकेटेड क्वेश्चंस भी करने वाले हैं, सो डोंट वरी अबाउट दैट. मैंने इसलिए सॉल्व एग्जाम्पल अलग से रखे थे ताकि हम लोग डिस्कस कर सकें. चलो, नेक्स्ट कंटेंडर इज तनीषा.
Yes, sir.
A torch bulb when cold has a resistance of 1 ohm. ठीक है, तो रेजिस्टेंस है 1 ohm. It draws a current of 300 milliampere when glowing from a source of 3 volt. अच्छा, ये तो कोल्ड की बात है. जस्ट अ मोमेंट. Okay, so resistance is 1 ohm when it is not glowing, when it is cold. ठीक है, but then they have said that it draws a current of 300 milliampere. I is equal to 300 milliampere, which is equal to 300 divided by 1000 ampere, which is 0.3 ampere. When glowing from a source of 3 volts, voltage है 3 volts का. Calculate the resistance of the bulb when glowing and explain the reason for difference in resistance. तो यहाँ पे हमें कुछ करना नहीं है, सिर्फ इसका रेजिस्टेंस ढूंढना है. तनीषा, can you help me?
Yes, sir.
Yeah, how do I do it?
So we'll apply formula V is equal to IR.
By Ohm's law.
Yes.
Correct. Now we'll put the values. First we'll write R is equal to V by I, which is 3 by 0.3, which is 30 by 3, which is 10 ohm. So the resistance was 1 ohm when the bulb was cold, when the wire filament was cold, and when the filament started glowing, its resistance became 10 ohm. Can you tell me why is this difference? What is the reason behind this difference? एक ही फिलामेंट है ना, उसका हमने लेंथ बढ़ाया ना उसकी थिकनेस को कम किया, कुछ भी नहीं किया, फिर भी रेजिस्टेंस 10 टाइम्स हो गया। क्यों हुआ ये?
Sir, because resistance increases with an increase in temperature.
वेरी गुड, रेजिस्टेंस इंक्रीजेस विद इंक्रीज इन टेम्परेचर। तनीषा,
Yes, sir.
याद रखना है इसको।
Yes, sir.
रेजिस्टेंस, कुछ फैक्टर्स है जो रेजिस्टेंस को कंट्रोल करते हैं। लेंथ ऑफ वायर, थिकनेस ऑफ वायर, मटेरियल ऑफ वायर, और एक है टेम्परेचर। टेम्परेचर बढ़ने से रेजिस्टेंस बढ़ता है। जब बल्ब ग्लो करने लगता है तो उसका रेजिस्टेंस बढ़ता है। ठीक है, नेक्स्ट क्वेश्चन। Okay, I want Arkadeep to help me with this question. You're there, Arkadeep?
Yes, sir.
Calculate the resistance of 1 kilometer long copper wire. The length is 1 kilometer. What should I do with it? I have to convert it into meters. Okay? So 1 kilometer is 1000 meter. Of radius 1 mm. So radius is 1 mm. Yes, Arkadeep, can you tell me what should I do with it?
Sir, I don't know.
You don't know, you have not seen the videos?
Sir, I have.
Then how you don't know? Resistivity is covered in that. You haven't seen the videos, I'm sure.
Sir, I have.
Then tell me the formula of resistivity, chal.
Sir, I just don't remember it.
How come? Tomorrow is your exam. Tomorrow is your exam. When will you study? I don't know. Okay, so this radius also we have to convert into meters. Now first we convert it into centimeter. For converting millimeter to centimeter, you divide it by 10. And then you convert centimeter to meter by dividing it by 100. So this is 1 upon 1000 or 10 raised to minus 3 meters. But that is not all. For finding the resistance, see, the specific resistance or resistivity is given. For finding the resistance, we have to know the area. Here the radius is given, so we have to find the area. So this is a wire whose cross section is circular, that's why the radius is given. So the area will be equal to pi r square, area of circle, that is 3.14 multiplied by 10 raised to minus 3 the whole square, that is 3.14 into 10 raised to minus 6 meter square. This is the area. So you know the area, you know the length, you know the specific resistance of copper. You can find the resistance. So resistance is rho into L by A. So rho is 1.72 times 10 to the power minus 8 ohm meter by A is 3.14 times 10 to the power minus 6. Okay. Now this is meter square, okay? And this is ohm meter multiplied by length. Oh, I did not multiply the length. Multiplied by 1000 meter. So this meter and meter will cut with this meter square. So we have 1.72 divided by 3.14 multiplied by 10 raised to minus 8 multiplied by 10 raised to 3, that is 1000, divided by 10 raised to minus 6. Yes. Orkudip, at least tell me the calculation part. Simplify this for me, please. Yes, Orkudip.
Sir, just a second. So 0.5 into 10 raised to 1.
Yeah, it is 0.547 times 10. So it is approximately 5.47 or 5.48. 5.48 ohms. Let me check the answer. Yeah, so they have rounded off to 5.5. 5.48 I'm getting, they are getting 5.5. But this is the method. So it's important to remember the formulae, conversion methods of these questions. Next, I want Pratik to help me. Pratik?
Yes, sir.
Yeah. When a potential difference of 2 volt is applied across the ends of a wire of 5 meter length, okay, so potential difference is 2 volt is applied across the ends of a wire of 5 meter length. Length is 5 meter. A current
Yes,
of
sir.
1 ampere flows through the wire. Current I, 1 ampere flows through the wire. Calculate the resistance per unit length of the wire. Resistance per unit length. Just a moment. Resistance per unit length. Then resistance of 2 meter length of wire. And the resistance across the ends of the wire if it is doubled on itself. Okay.
R is V by I.
Hmm.
Sir, for resistance, we'll use the formula of V is equal to IR by Ohm's law.
V is equal to IR, Ohm's law, so I is equal to V by I, that is 2 by 1, which is 2 ohms.
Ohm, yeah.
Okay, so this is the resistance of 5 meter length, right? This is the
Yes.
resistance of 5 meter length. So what will be the resistance per unit length?
Resistance per unit length will be Uh,
So for 5 meters, the resistance is 2 ohm. Per unit means 1 meter.
1 meter. So 2 by 5,
2 by 5 ohms. Can you tell me how much?
0.4
Correct.
ohms.
So what will be the resistance of 2 meter length?
So 0.4 into 2, which is 0.8 ohms.
Resistance of 2 meter length is equal to 0.8 ohms. If the length doubles, the resistance become double.
Also doubles. Yes.
But the last question says that the resistance across the ends of the wire, if it is doubled on itself.
What
Now,
does it mean, doubled on itself?
doubled on itself means suppose this is the wire. So what I do is I fold it from here and make it double on itself like this. This part
Okay.
comes over here. So
Yes.
in this, two things are happening. The length of the wire,
Decreases and the thickness
becomes
increases.
half, and thickness becomes double. Length of the wire becomes half and the thickness of the wire becomes double.
So resistance decreases by 1/4.
Very good. So we know that resistance is directly proportional to the length. So if the length becomes half, the resistance becomes half. And we know that the resistance is inversely proportional to the area of cross section. Now if you double the wire on itself, the area of cross section becomes double, so the resistance becomes half further. So the resistance becomes 1/4 its original value. But here it is not clear that which wire they are talking about. Are they talking about the original wire? If they are talking about the original wire whose resistance is 2 ohm, that resistance after the wire doubles on itself will become 1/4 of its original value, that is 2 by 4, which is 0.5.
0.5.
Yeah. But if they are talking about this wire which is of 2 meter length whose resistance is 0.8, if you
Yes.
divide it by 4, it will become 0.2
0.2.
ohms. Yes. So we don't know yet which wire we are talking about. So either it is 0.5 ohm.
Or 0.2 ohm.
Yes, let's check. Yeah, so yeah, it was 0.5 ohm.
Yes.
0.5 ohm means they are talking about the original wire, right?
Yes.
So they have done it with little long method. We have done it directly by using the relationship of length with resistance and the relationship of thickness or area of cross section with resistance. If you halve the length, resistance will become half. If you double the area of cross section, the resistance will also become half. Yeah, so our answer is correct.